Okay, welcome back to some more fun with math. Here I wanted to look specifically at what are called least common multiples, or LCM. A least common multiple is essentially the smallest number that is a multiple of all the given values. So whatever methods or numbers you are looking at, a least common multiple would be the number that is in common with all of your multiples, and it is the smallest. Okay? There are a couple different ways that you can go about attempting to try and find a least common multiple. The first method is called listing your multiples. Now this is more of a lengthy method depending on the numbers you've been given. But it is also a fallback method. If you can't remember any other way to do it, then you can always simply go about listing your multiples. So the way it works is just as it sounds. I want to find the least common multiple between 10 and 15. So if I'm going to list them out, I'm going to start with 10, and I want multiples of 10. So a multiple would be either adding itself each time or multiplying in a step-up fashion. So when we're talking about multiples, we are talking about either doing, say, 1 times the number and then 2 times that number and then 3 times that number, or we are looking at starting with that number and then doing that number plus that number, and then plus the number again, and then plus the number again, and so on and so forth. So here I'm going to start with 10, so my first multiple is 10. And then my second multiple would be, say, if I use my multiplication, it would be 10 times 2, which is 20. That's also the same as doing 10 plus 10, so 10 plus 10 is 20. You then have to go up another step, which would be 30, then go up again, which would be 40, then again 50, and so on. Now the other multiple that I wanted to look at, or that I have, is 15. So again I have to do the same thing. So when I start at 15, and I'm going to look, does 15 in common with anything here? Well, that answer is no, so then you need to move on to the next one. My next multiple of 15 would end up being 30. So do I have 30 in common? Well, I do. So if you notice, I have 30 that appears in my 10 list and a 30 that appears in my 15 list. Since that is the smallest value that is insane, or the same between both of them, my least common multiple is 30. We can do the same thing with these next numbers. So one thing that you could do, if you notice the example ahead, I started with the small one and worked my way up. Well, you could also start with the larger value and you work your way down. So I would list a few. So I know I have 18. My next multiple would be 36. Then I have 54. Then I have 72. Then I have 90, and I would keep going. If I look at 5, well, I know I'm going to have 5, 10, 15, 20, 25, 30, 35, 40, and so on. I eventually would come to 90, 95, etc. I would do the same thing with my 3s. 3, 6, 9, all the way up, and I eventually will get to 90 and keep going. So what's in common here? Well, the lowest one that's going to appear in all three numbers is 90. And notice I said it's a very tedious process, because the smaller the value in comparison to a larger value means you're going to have to list a lot of values out. Okay? But in this case, that LCM then would be 90. A quicker method, or which I consider to be a much quicker method, is the second method here, which is called dividing out the primes. Essentially what that method says is that you're going to start with your value, and then you are going to divide out your primes in a similar fashion to doing prime factorization. Then, once you have divided out all your primes, you are only going to select the value that has the largest exponent, and that's going to be what you multiply together. So what do I mean by that? Well, let's look at it. If I start with 81, I know 81 can break down into 9 times 9, but 9 can break again into 3 and 3, 3 and 3. So if I look at it, 81 actually breaks down into 3 to the 4th power. Now let's take a look at 90. 90 can break down into 9 times 10, where I know my 9 will break into 3 and 3. 10, however, will break into 5 times 2, and that's as far as it goes. So if I look at 90, I really have 3 squared times 5 to the 1st times 2 to the 1st. I only want to use each number once, but I want to use the largest of each number. So if I look, I have a 3 and a 3, so I need to look at their powers. This is 3 to the 4th, this is 3 squared. So I want to use 3 to the 4th. I then have a 5 to the 1st, but I don't have any 5s, so this would be the largest. I have a 2 to the 1st, but no other 2s, so this would be the largest. So to find the LCM, says I'm going to multiply 3 to the 4th times 5 to the 1st times 2 to the 1st, which will actually give me a value of 810. Now, could you imagine having to write the multiples of 90 and 81 all the way up to 810? Which is why dividing out your primes is the faster process to use. Okay. Now, if I want to be able to state how many times each value ends up dividing into the LCM, well, that simply says you have to take your LCM and divide it by your value. So here I have 810 divided by 81, and that is going to give me 10 times. I also have 810 divided by 90, which is going to give me 9 times. Okay. So for the problem, find the LCM of the given values, we did. For the part that says state how many times each value divides into the LCM, that's what this is. Let's do it again. I have 12, 18, and 40. So let's go ahead and take a look. We can start with 12. And I know 12 can break down into, say, 3 times 4. And I know 4 breaks down into 2 times 2. So this is going to be 3 to the 1st times 2 squared. Now 18 will break down into 2 times 9, and 9 breaks down into 3 times 3. So this is going to be 3 squared times 2 to the 1st. I then have 40. 40 can break down into 4 times 10. We know 4 breaks into 2 times 2, and 10 breaks into 2 times 5. So this is going to be 2 to the 3rd times 5 to the 1st. So we have to identify the largest. So let's start. I have 3 to the first and 3 squared. When I'm looking at that, the larger one is going to be 3 squared. Now I have 2 squared, 2 to the first, and 2 to the third. Well, 2 to the third is the largest, so we use that. And then I have 5 to the first, so we'll use that. So my LCM here is going to be 3 squared times 2 to the third times 5 to the first. And in doing so, you end up getting 360. Now for the second part, we have to know how many times each value divides into 360. So I have 360 divided by 12, and that should give me an answer of 30. I then have 360 divided by 18, and that's going to give me 20. I then have 360 divided by 40, and that'll give me 9. So there I have it. I have the actual LCM that I'm using, and then I have the number of times that each value divides into it. Okay. Alright, now let's look at some really big numbers. And again, we can attack it the exact same way we did before. So we can start with 625, and there's a few things that we know about 625. It ends in a 5, which means I know that I can pull a 5 out, and when I do that, it leaves 125 behind. It ends in 5 still, so I know I can pull out another 5, which is going to leave 25 behind. Ends in 5 still, so I can pull out a 5, which leaves a 5. There's nothing else I can do, so this is going to be 5 to the 4th. The next number I have is 75. Again, it ends in 5, so I can pull that out, which leaves 15. Break my 15, I get a 3 and a 5. So what does this give me? This gives me 5 squared times 3 to the first. I also have 500. It ends in a 0, which means I can pull out a 10 or I can pull out a 5. So if I pull out a 5, leaves me with 100. I can pull out another 5, which leaves me with 20. I can pull out a 5, which leaves me with 4, and then 2 and 2. So this is going to give me 5 cubed times 2 squared. Last, I have 25, which breaks into 5 times 5, which is 5 squared. So I have to compare them again. I have 5 to the 4th, 5 squared, 5 to the 3rd, and 5 squared. So I'm going to use 5 to the 4th. It's the largest. I then have 3 to the 1st. I don't have any other 3's, so I use it. I then have 2 squared and none of the other 2's, so I use it. So when I'm looking for my least common multiple, my LCM here is actually going to be 5 to the 4th times 3 to the 1st times 2 squared, which is going to give me 7,500. Now the last thing that we need to look at is we need to look at how many times does each divide out of the 7,500. So here I have 7,500 divided by 625. And so this is going to give me 12 as a result. I then have 7,500 divided by 75, which is going to give me 100 as a result. I have 7,500 divided by 500, and here this gives me 15. And last, I have 7,500 divided by 25, which gives me 300. So there we have really big numbers and still being able to make it work. Okay? Now, sometimes we're not just simply going to be given the problem, we're going to have to read it out of an application or a word problem. So I wanted to give a couple examples of how to do that. First says, 3 neighbors mow their lawns at different intervals during the summer months. The first one mows every 5 days, the second every 7, and the third every 10. Part A wants to know the frequency that they mow their lawns on the same day. So what is that actually asking? It's asking you to find the LCM. So what do I know? I know the first one I have is 5. Well, 5 is prime, so that breaks into 1 and 5. The second one is 7, which is also prime, 1 and 7. And the next one is 10, which is not prime, but it breaks into 2 and 5. So of these, I have a 1, I have a 5, I have a 7, I have a 2. You only use each number once. So to find the LCM, my LCM here says I'm going to do 1 times 5 times 7 times 2, which gives you 70 as a result. Now the second part says how many times does each neighbor mow in between the times they all mow. So in other words, what we're looking for is we want to know the number of times it divides out of the LCM. So in order to do that, says that we have the number of times that you mow together divided by each mow. So I have 70 divided by 5 is going to give me 14 times. I have 70 divided by 7 is going to give me 10 times. And I have 70 divided by 10 gives me 7